Hi, ladies and gentlemen. This is Mr. Green. This is another of my lessons in Algebra 1. We're in Unit 4 and we're looking at multiplying and dividing, but I wanted to go into some problems that you might be looking at. Okay? When we look at these problems, they don't just express them as equations that you have to solve. A lot of times, what they're doing is they're giving you word problems, and it is as important to know that you're using the right equation as it is to know how to solve that equation. If you don't use the right equation, you won't get the right answer. So, what I'm going to do here today is show you how to set up a few of these word problems. This type of problem here is called a distance problem because you're using a very simple formula. You're using the rate times the time is equal to a distance. This formula right here is what I'm going to use. Now, the problem says a cargo plane flew from the U.S. across the Atlantic at 274 miles per hour. How did I know I'd be using this problem? See how that says miles per hour? That's a rate. And they said, and they flew back to the U.S. at 294 miles per hour. I'm going to circle both of those. Those are both rates. Now, I know that if they flew from the U.S. across the Atlantic and then back to the U.S., they flew the same distance. Think of it this way. If this is the U.S. sitting over here, and this is the Atlantic sitting in here, and Europe sitting out over here somewhere, with England up here, okay? They flew from here to here. Then when they fly back, they go from here to there. It's the same distance. So, given that the first trip took 2 hours longer, what time? That was my second part here, right? So, this trip, the first trip in red, took 2 hours longer than the return trip. And they want to know how long was the return trip. Long. Two different ways of thinking of that. One would be distance, one would be time. I'm going to show you how we would do it as far as time is concerned. I'm going to take the original distance, 274. Knowing that that was 2 hours longer, I'm going to say t plus 2. The return trip, 294, that was t. That's going to tell me the time of the return trip. Since the distances are the same, I can set them up as equal to each other. This one over here, distributive property, 274t plus 548, 2 times 74, 548, is equal to 294t. Now when I subtract this from both sides of the equation, I'm going to get 548 is equal to 20t. I'm going to multiply by the reciprocal of 20. It'll be 20 over 1 and be 1 over 20. And I'm going to get 548 over 20 is equal to t. Using the commutative property or the symmetric property, I'm going to switch it around, and I'm going to say that t is equal to 27.4 hours. I found the time. That's how long in time it took, 27.4 hours. But if the question was, how long was the return trip? Maybe they're wanting the distance. So I could at this point say 294 times 27.4 would give me the distance. And I can do that. That is just a multiplication that I am not able to do in my head. So I'm going to bring up my handy dandy calculator and say 294 times 27.4, and I get a number of 8,055.6. 8,055.6. That's the distance that they're going to go. But is that the same distance they flew on the other way? Let's try that one. 274 times 27.4 minus 2. I'm sorry, plus 2, because it was 2 hours longer. So that's going to be 274 times 29.4. Well, 27.4 plus 4. Once again, I can't do that in my head. So 274 times 29.4, and I will wind up with 8,055.6. Same number. See, distance was the same, right? So I don't think they're asking me distance-wise if I get the same number here, okay? I'm sure what they're asking is, what's the time? And that's what my answer is going to be right there. Cool? Cool. Okay. This problem is called a mixture problem. A mixture problem is one in which I'm going to be told some percentages. Joan mixed, see how it tells me right here? She mixed 10 milliliters of a salt solution with 11 milliliters of a 46% salt solution to make a 40% salt solution. Find the percentage salt of concentration of the first solution. Well, I'm going to let this be my variable, percent of salt concentration in the first solution. I know that we're mixing these, so I'm going to say 10 times P. P is going to be my percentage in this situation. And they're mixing that, that means they're pouring them together, so plus 11 milliliters of a 46%. So that's 0.46. Where did that 0.46 come from? That's that percentage right there, right? As a decimal. Times 11 milliliters. And that's going to be equal to, well, they're going to make a 40% salt solution. So that's going to be 0.4 times something. Well, guess what? They made 10 milliliters and 11 milliliters. You add those together, you get 21 milliliters every time. Now it's just a matter of doing the math here. And I can use my calculator again. Okay? So I'm going to say 0.46 times 11, and I'm going to get 5.06. So I can replace this with the 5.06. This 0.46 times 11 gave me 0.56. Same value. If I multiply 0.21 times 0.4, I get this 0.84. I'm going to subtract this from both sides. I'm going to have 10p is equal to 3.34. I'm going to divide by 10 or multiply times 1/10, and 0.34 divided by 10 is 0.334. My percentage is 0.334. So expressing that as a percentage is 33.4%. That would be my answer. You see how I did that? Not really difficult, just a matter of being able to set it up correctly. Okay? This one is a cost type problem. Benny received $60. How much money did Benny get? $60. That's not hard. And 7 movie tickets for his birthday. Okay? I'm going to circle that. 7 movie tickets for his birthday. Okay? He went to a sporting goods store and bought a baseball glove, a baseball, and a bat. He had $15 left over. Wait a second. How much did he spend on the baseball gear? Well, I'm going to let D, or dollars, be how much he spent. And if he spends money, you subtract it. If he made money, you would add it. So I'm going to subtract dollars from this. And that's going to be equal to $15. Because that's what he had left over. That's what he had in change, right? Now, I want to point out something. Did the 7 have any meaning in this problem? Absolutely not. The 7 movie tickets were just extra information that we did not need to know to solve this problem. So I've got 60 minus D is equal to 15. So I'm going to subtract the 60. Why am I subtracting 60? I want you to look at it. 60 plus a negative D It's being added to the d, right? So if I subtract 60, it's the opposite operation. And what I wind up with is a negative d is equal to a negative 45. What I'm going to do is I'm going to pull a little trick. I'm going to multiply times negative 1. If I multiply times negative 1, I'll get d is equal to 45. So, how much did he spend on baseball gear? $45. Okay? Now, in case you didn't remember this little trick, how could I have done this differently? Well, I'm going to show you another way of doing this. If I have 60 minus d is equal to 15, one of the things I can do is the d is being subtracted. I could add that dollars to both sides. It's just a variable. Nothing wrong with adding it. And I wind up with 60 is equal to 15 plus d, or d plus 15. Now I can subtract 15 from both sides, and I wind up with 45 is equal to d. Well, that's the same thing. Community or uh, symmetry property of identity, I can switch that around and get that d is equal to 45. Same answer. Okay? And I didn't have to multiply by the negative 1. But multiplying by the negative 1 gave me the positive value. Okay? So, I'm sure there's going to be a few questions. You're going to look at a problem and go, I don't know how to set that one up. Try several. If you have other issues, I'll be willing to talk to you about them, bring them to tutoring, or come see me in Class Connect. And I'll talk to you next time.